Hello and welcome everyone to this information session on the new Pulp tasking system. Today's session will be quite informal and have a questions and answers format. Throughout the session, we welcome any questions that you may have and feel free to drop them into the YouTube live chat during the conversation. And just a note about the live stream as well. Everything looks okay, but as you know, it might drop, there might be buffering, etc. If this gets very annoying, very inconvenient, just please drop a note in the chat and let me know, and we will find an alternative. And just to start off, I'd like to introduce you to Matthias Dellweg. Matthias joined the Pulp team after contributing to both Foreman and Pulp for about 3 years. He's mostly contributing to pulpcore, the container plugin, and also to the Pulp 3 CLI. As a physicist, Matthias sometimes brings a unique natural science view to the table. And to kick things off, I'm going to pass things over to Brian, who is going to start the session today. So it's over to you, Brian.
Great, thanks, and welcome. So why don't we go ahead and get started with the interview of Matthias, and who has made this tasking system. Matthias, just to get us started, can you give any sort of background info that you'd like viewers to hear or understand to kind of prepare for today's conversation?
Yes, welcome to this session, everyone. The current tasking system is based on what we had in Pulp 2. Pulp 2 was a rather monolithic service, which was running always on one computer. And so it was kind of okay to have the tasking system as it is. And it was running in multiple processes where you have a resource manager, and the resource manager distributed tasks to other workers. And the workers were then kind of bound to the resources that the task was needed. And this all worked quite well. But now with Pulp 3, we want to have a more distributed approach. We want to make the application cloud ready, so to say. And so I believe at this point this needed changing.
As you, thanks for explaining that. So as you mentioned, Pulp already has a tasking system. Why does it need a new one? Can you maybe give us some of the details about some of the motivations for making the new tasking system?
Yes, as I said, the tasking system is roughly the same, at least in architectural way, to the one that was in Pulp 2. But at the time, we kind of figured out that there was a throughput limit. The resource manager is a singleton in the architecture, and there was only a throughput of about 2 tasks per second in the resource manager. And at the same time, being a single point of failure, this resource manager was not highly available, so you couldn't just run multiple of them. And another downside in the architecture is that the communication between the worker processes and the application processes are performed via Redis queue. And so the information about a task was always distributed in 2 databases, being the Pulp database, which is based on Postgres, and the RQ database, which lives in Redis. And last but not least, with Pulp 3, tasks started to have the ability to depend on more than one resource. And this led to a theoretical possibility that the resource manager was unable to deliver the next tasks until tasks finished. And this could lead to idle workers while there would still be work that could have been worked on. So this was non-optimal in system utilization.
That sounds like a whole bunch of motivations. I think I heard at least 4 there. So for the new style tasking system, which I've also heard is called the queueless tasking system, which I think we'll talk a little bit more about in a little bit, when is it available for users?
Well, it is merged in the main branch of our pulpcore repository, and this means it will go out with the next release being 3.14. And I have a strong feeling this will be released this week.
Yes, I agree. The current release date, I believe, is scheduled for Thursday. We evaluate that kind of on an ongoing basis leading up to that. So it'll be available this week. That's great. And how do users who upgrade to pulpcore 3.14 or later, what do they need to do to receive and start using this tasking system?
Basically nothing, because we decided to enable it by default. And that means users upgrade the system, they restart their services, and the new tasking system will kick in. And hopefully they won't even notice a change.
Great. So it sounds like the upgrade experience is easy. It's new and it's also being enabled by default. What happens if a user wants to go back to the old style tasking system? Do they have to use the new style tasking system?
Well, there's two parts to this answer. First, no, they don't have to, because we decided we develop the new one side by side with the old one. And there is an option in the Pulp settings called Use New Worker Type. And if you switch that to false and restart your services again, then the old tasking system will start up again. If you really want to switch back, then we recommend that you drain your task queues first, because the tasks may end up in undefined states otherwise. If you already know you don't want to switch before upgrading, it's safe to just set this option in the old version, and then after the upgrade, the new tasking system will just not start. The second part to the answer is be prepared. We are going to remove the old tasking system in 1 or 2 releases, probably. And then there's no option anymore.
Okay, great. Well, it sounds like users have an option to go back if something goes wrong or if they have a preference for that, even though the new one's on by default. So that's really good, I think. Earlier you mentioned that there was a high availability goal, and that the old system was not had a single point of failure and was not highly available, but the new queueless tasking system is. How does the new queueless tasking system provide high availability?
Well, it removes the resource manager, which was a singleton in the architecture. And this means now every service that is running for Pulp 3 can really be run in multiple instances and on different hosts and different containers. And I think they still need to be in the same cluster in the end. But all the services, including the Postgres database, will be able to be scaled up for high availability and also for performance.
That's great. I know our users are going to enjoy that. So you mentioned the resource manager. What happened to the resource manager with this new style, the queueless tasking system?
Well, the design just doesn't have it, so it's going away. And for easier deployment, we still have the process around in the installer, and therefore if you start the worker type as the resource manager, you will just have a dummy process that is sitting around waiting and doing nothing. So don't be afraid if you switch to the new system and you see a resource manager. This is not a problem.
Cool. And if you start the new, so it sounds like I'm hearing, just to confirm, will it error or any sort of errors be emitted if you start the resource manager accidentally, even though you're using the new style queueless tasking system?
No errors, just you will see a process that doesn't necessarily need to be there.
Cool. That's great. So earlier you mentioned that there's the new style queueless tasking system is a lot faster and has better performance. Can you give us some idea how much faster is it?
Well, it's hard to put in numbers, but basically, if you start more workers, it will have a faster throughput, because every single worker will look for tasks, and there's not the single process that is delivering tasks, which was the real bottleneck in the old system. And again, that is the resource manager.
Well, that sounds pretty great. I know that, yeah, so the old style tasking system, I think I heard, has two tasks per second, something like that.
Yes, so that means like a half a second overhead for every task, and then still the overhead for processing.
Cool. So it sounds like if you start maybe like, what, 16, 32, 64 workers in the new system, you'll have a pretty tremendous tasking throughput.
Yes, I had made some benchmarks, and it looks like 16 workers is kind of the sweet spot here on a single machine.
Yeah, and speaking of benchmarks, didn't you publish a blog post about this system that has some actual graphs on the performance benchmarks while we're talking about benchmarks? Did I remember? Am I remembering this right?
That's correct. And there's described on which kind of system these benchmarks are taken. And one of the downsides at the moment of the new tasking system, the queueless one, is that more workers will look at the database for tasks at the same time. And if too many of those hit the database, then that will again give a performance hit. And that's the reason why I think 16 workers is the best number at the moment. Well, it's a new system, and we have some ideas to come up with that, but we'll keep you posted.
Blog post perhaps in the chat. I can help with that later. But if regardless of whether we do or not, that's on pulpproject.org/blog. And the next thing I was hoping to ask about is a little bit about the reliability. So is the new queueless tasking system, is it more reliable, and why would it be more reliable than the old previous tasking system?
Well, I believe it's more reliable, and that's for one. We no longer have the data of tasks kept around in two databases, which kind of always leads to inconsistencies, and those inconsistencies in the past led to what was always called hanging tasks, or hanging workers even. And the second thing is the new system doesn't rely on intricate cleanup code if a worker dies, but it's using Postgres advisory logs, which will be cleaned up automatically once the database connection of a died worker, for example, or a shutdown worker will time out. And so the cleanup code got way simpler, and simpler code usually means more reliable.
Cool, that's great. I know that's, reliability and hanging tasks have been something that our users have been really concerned about. And so I think probably that's one of the biggest motivations for wanting to try out and use and adopt this new system. You mentioned worker cleanup and how there is less cleanup. So is that related? How does that relate to cancellation of tasks? I know with the old system, the previous tasking system, there was a good amount of unexpected task cancellation. Say you restarted a worker and it had some tasks assigned to it that it had not yet finished, those tasks would become canceled somewhat unexpectedly because the user never issued a cancel. Can you talk about how the new system handles cancellation? Will users' tasks be canceled in some situations or not?
Well, yes and no. If a user cancels a task, the task will be canceled. Okay, that's expected. On the other hand, if a worker is running a task and this worker is shut down or dies or whatever, then the corresponding task will also be canceled eventually. And there's just nothing we can do about it because a half-run task is nothing we can repair from. But a big difference of the new system and the old system is that in the old system, you could say it's a queue-based system, but actually it's a system of many queues because tasks were dispatched to individual worker queues based on the resources they needed. And that's the core of the problem here, because the resource manager would pile up tasks in front of a worker, that used the same resource. And now if the worker died, it would the cleanup code would cancel all the tasks that were already piled up. And in this new system, where there is just no queue, no task will be assigned to a worker before the worker actually wants to start running it. And therefore, there's just no reason to cancel tasks that weren't yet touched by any worker.
That's great. So
yeah, so to say that, I believe this problem has gone away.
Cool. That's great. I know that's probably actually one of the oldest bug or story requests in our tracker, actually. So I'll be very happy to see that one close. The tasks don't no longer cancel unexpectedly. Earlier, you mentioned that this new system does not use Redis, but Pulp is in Redis is still in the Pulp architecture diagram. So does the new tasking system use Redis at all?
Well, the tasking system is not using Redis queue anymore, and by that also not using Redis anymore. But the Pulp architecture will still keep Redis around because we have a work in progress where we want to speed up the content app delivery by using Redis to cache answers.
Cool, great. So it sounds like Redis will still be kept around, just no longer used by the queuing system anymore.
There's no need to change your installers today.
Perfect. Then, one of the questions that's come up in the past, and I was hoping you could tell me more about, is the use of this term queueless. Traditionally, in tasking systems, the queue is the workhorse of the trade. And yet this is a queueless tasking system. Can you talk a little bit about why Pulp isn't using queues for its tasking system?
Sure. Pulp has a certain first come, first serve policy based on the resources used by a task. And so this kind of means that the resources that a task needs imposes an order on the tasks to be executed. And if you have a queue, then this also imposes an order on the task. And this means we cannot just put tasks in the back of the queue and have a bunch of workers at the front of the queue picking off those tasks. In the traditional tasking system, this was, as I tried to explain earlier, solved by a resource manager being at the front of the first queue and then delivering the task to individual queues of the other workers, which basically made those other queues for resources. And, well, in the end, both systems are not the traditional one queue tasking system, if that answers your question.
Yeah, I think what I'm hearing is that it's there are opportunities to process work which the traditional first come first serve delivery order of queues is not, creates inefficiencies in the way that Pulp. Pulp has an opportunity to process more additional tasks, but they're just further back in the queue.
Exactly.
Yeah. So it almost sounds like like this new system is almost like an admission control system, like a call admission control system, like things arriving to a network, and there's an algorithm of which ones are allowed or not allowed. So that's kind of what it reminds me of. So speaking of how it works, we've talked kind of at a high level about its benefits, and I don't want to get into a whole lot of detail in terms of the implementation, but could you just give us some idea from a high level, how does the algorithm work?
Okay. It's a bit like a team of developers, and you have a lot of tasks to do, and keep in mind those tasks use resources. So whenever some worker is idle, it goes and looks at this list, which is a database table in Postgres at this point. It will start with the oldest task and see if this task, well, obviously the oldest waiting task, and it will look if this task is ready to be performed. For that, all the resources must be free. So it needs to look at all the running tasks first, record all the resources in use. Now it will look at this task and see if all the resources are free. If this is the case, it will try to grab the lock for that task and just perform it. If it fails to grab that lock, it will add the resources needed by that task to its list in memory, and will look at the next task and again do the same algorithm for looking if all the resources are free. If one of the resources is in use or at least needed by a prior task, it will again add those resources and look at the next task. And at this point, it will go through the list until it finds a task to work on and it actually gets the lock for it. And if it reaches the end of the list, it goes to sleep until it's notified that some new work may be available.
Cool. So yeah, it sounds to me like each worker, it's a distributed algorithm, and each worker is trying to find work that it can handle, and it can be sure that it's has an exclusive access to any particular piece of work due to the Postgres advisory locks.
Exactly. And it's completely distributed, which is adding to the high availability and scalability.
Perfect. All right. Well, thank you for that explanation. I just have one more question, and then maybe we'll take some questions from the chat if there are any. But what I would like to ask you is, how can users either get help with this new tasking system or can give feedback on this tasking system?
Well, usually you can reach us all on Matrix or IRC, and we have a mailing list. But at this point, I will just refer you to pulpproject.org, our website, because all the communication channels had some recent changes and maybe more are to come. So the website will always be the one single point of truth where you can read how to reach us.
Okay, perfect. Well, I just want to thank you for your time today, and also for all the effort and care that you've put into making this great for all of Pulp's users. And with that, I'd like to hand it back over to Melanie to see if there are any questions from the chat before we conclude.
Sure thing. So as you were talking, you answered the question that we had from, and it's, I suppose before I get started, it's not too late to ask questions. So if you have something that you're thinking about or some feedbacks or comments, there's a few minutes left now. So first of all, as you were talking, Jeremy had asked, how does the queueless tasking system work and what does it do instead of queuing? But just, you pretty much answered that almost in complete simultaneity with Jeremy. Chris Roberts from Catello had paid a number of compliments to the new system also. And then just one other comment from Chris Myers, who mentioned, first of all, that AWX uses Postgres notify and listen, but that it also looks like Pulp is using that as well for the Pulp worker.
That's correct.
Yeah.
Exactly, especially for waking up sleeping workers again.
Cool. And then just one other question from Chris. Is there any business logic that would create task dependency?
Pardon?
Is there any business logic that would create task dependency?
The dependency. Well, the resources create the dependencies between tasks. So if, for example, you have a remote and you want to sync two repositories with the same remote, you can fire off two tasks for that, but the first task that gets to the database will be the first one to be performed and the other one will wait. And that's the dependency here. And that's also the speciality of Pulp, where this algorithm needs to determine which tasks need to be performed first.
If I may also add, the resources, like one way to think about the resources, which is more or less another way of saying what Matthias had outlined, is that they serialize tasks. So if two tasks or some number of tasks need the same resource, those tasks are then serialized. And so, for example, this requirement comes from just two simple examples. One is for syncing and then publishing, for example. If the client says, I want to sync this content into repository foo, and then I want to publish repository foo, it's important that those operations happen one after the other. And so the resource in that case would be repository foo. But also things like I want to sync a repository, and then I want to change the remote on a URL, or I want to change the URL for a remote, and then I want to sync the repository. It's important that the change on the remote occurs first before the repository sync occurs. And that doesn't happen, concurrently. So that's kind of the serialization goal of Pulp.
Thank you both. And are there any other questions? Fabrizio's here, even though he's on holidays. Hi, Fabrizio. So I don't think so. So I suppose just while we wait to see, are there any other questions? If you are watching the recording of this, just feel free to write to us on Matrix. And as you know, we're always trying to improve communication in the community. So we are updating some items, some methods of communication. So just check out our website, pulpproject.org, and our blog and our contact pages there for the most up-to-date information about the goings on in the community. I don't see any further questions, guys. So Brian, Matthias, I'd like to thank you very, very much for taking the time to come along today and talk about this upcoming change to the tasking system. We will publish an announcement when the release is available with on our blog and on our different lists. We will update you. And if you have any questions after we end today, just feel free to reach out to us. And thank you all so much for showing up today. Thank you for your time. Thank you for your comments, and we will see you again soon. Okay, take care.
Thank you. Goodbye.